Okay, hopefully you've all had your thinking caps on and you have some questions for our esteemed panelists. The first, Todd Grimm, who only spoke recently, so hopefully you all saw his presentation, veteran of the industry, forgotten more than most people know, etc. As I said before, he really does keep on top of the ins and outs of this industry, and it's been a very important resource for us in terms of ensuring that we are up to date with everything that's going on. Next to him we have Andrew Rush from Made in Space, which is, as it says on the tin, it is making things in space using additive manufacturing, which is pretty exciting, pretty challenging, I'm imagining. Next, Joe DeSimone from the Carbon3D. Carbon have probably been one of the most exciting announcements that we've had in 2015. And as we heard from his presentation before, it came in on the back of speed. That was the wow factor in the first launch, but there's much more to it than that, and it really did demonstrate well my point that 3D printing is exceptionally complex. It isn't just squirt something out onto a pad, as most people think. And then Scott Schiller from HP. HP, again, they made a huge splash at the end of 2014 when they announced that they would be joining the 3D printing industry with their own technology, a technology platform that again, could be game-changing for this industry. Consumer 3D printing is really why we're here now at CES, I think. We first came in 2013 and there wasn't any on the show floor. And the knowledge of it was very low. To what extent has the hype cycle surrounding consumer and desktop 3D printing in particular been a good or a bad thing for the industry as an entirety? Not necessarily just for your own businesses, but as an overall. But we'll start with you, Todd.
Do we have to?
We have to.
No, I think it's been both good and bad. With the conversations drawing awareness due to the hype, it brought a lot of attention to the industry from factions and elements, demographics that we wouldn't have gotten before, and gave us this lift. And that lift gave us financial fuel, drew in investment dollars, so that's all good. However, on the downside, or the negative side of that, it created a false impression of the technology. Jim, as you indicated, it's not as simple as squirting out some goo and making parts. So it gave an impression that push a button, immediately you got a beautiful part and it'll replace what you can buy at Walmart, on Amazon.com, or at Target. So good and bad. But I do think that the good outweighs, although maybe marginally, the bad. So I'm pleased that it happened. And I'm also pleased at the same time that we're on the backside of the hype and we're getting into more of a rational perception of the technology and rational thought of where it should go.
Okay, Andrew, same to you. Has it had any impacts, do you think, on your specific part of this wider industry?
Yeah, so I would say that Made in Space is in this portion of the industry where we're taking 3D printing and we're trying to solve really hard problems with it. Like, we're not necessarily producing a machine that's going to appeal to a whole bunch of consumers. If it appeals to the 6 people in orbit, awesome. We did our job. But when the company was founded in 2010, and we would go and talk to people at NASA and say, oh, we want to put a 3D printer on the space station, and here are all the reasons why it's awesome. We go through this lovely presentation, and then at the end of the presentation, you'd have invariably a few people in the audience or in the meeting say, what's 3D printing? And that's a question we don't have to answer anymore because of the hype, which makes it easier for us to have a more sophisticated, sort of solutions-based conversation about the technology. So I would say that's really a great benefit for Made in Space in particular, and then for companies like us that are trying to approach a more niche solution-driven technology development. I would echo what Tom said, that we had this this sort of Star Trek replicator idea of what 3D printers could do. You had a lot of especially in Kickstarter, you had a lot of people make some really glossy videos that made it seem like it was fire and forget kind of technology, and we all know that that's not true, which definitely I think caused a pretty significant backlash. And thankfully we're hopefully getting through that.
Okay. So maybe I have a slightly different take. I'm absolutely blown away by the maker community and everything that's going on there. And maybe it's a little bit of my roots in an academic setting. But I think that the crowd-accelerated innovation that's taking place in that community is absolutely amazing. And you walk the show floor and you see all these different approaches for desktop printing. It's striking and it's amazing, and would love to help foster that as much as possible. You know, responsibility at a company is a need for focus, and you know, especially a faculty member leading a company. Everyone's got eyes on me to make sure I'm focused, which is not normal for a faculty member. But you know, we're trying to do something that's really, really hard, and that's the 3D manufacturing, and trying to focus on filling something that looks to be a gap or an unmet need there, and try to have a strategic differentiation to allow manufacturing to take place. So it's not where we focused initially, the consumer maker community, but it's one that I'm just blown away with and would just love to try to help foster.
Yeah, I think actually my answer would be almost identical to Joe's. Anything you can do to get the technology into the hands of the users, any of the users, is, I think, a net positive thing, because it gets people to start thinking differently about the design process. And I think that that's one of the biggest things that's going to take time, maybe even a bit of a generational change. The other thing is, I would also point out, I have a 10-year-old son, and he's absolutely captivated with this technology. And he spends an enormous amount of time in games like Minecraft, where they're thinking in 3D. They now see this as a very viable technology. They don't need to concern themselves with the Wall Street issues that some of the consumer businesses are having. But I think that overall, I think it's absolutely fabulous. And the other thing is the fact that it's a democratizing technology in that context, or on that scale. It allows people to get some ideas up and running, and more ideas have a chance to get out to the market. So overall, very, very positive.
And just in terms of, this is something that we have argued about for many, many years. You've all mentioned manufacturing more than 3D printing. This is a manufacturing technology for most people now. Is 3D printing, or should we still be calling it 3D printing? Has that had its, I mean, it's been very useful for the industry to I think it was Todd who said we need to compartmentalize things. We've lumped it all together as 3D printing, whether that's on the ISS, or that's in medical, or it's in a shop printing out a bobblehead or something. How best can we start to separate that, or are you happy within your own industries to just say, right, this is 3D printing?
Yeah, yeah. I mean, certainly the focus on 3D manufacturing is what we're trying to do, and you know, I think that legacy term will never go away, just like rapid prototyping. But you know, I think about going beyond prototyping and actually have manufactured parts that are real parts that have performance that fit performance needs is really the key, and the terminology will hang around for a while, for sure. I don't think it's detrimental.
No, okay.
I think the problem that we run into with the term 3D printing is that it's indelibly linked to plastic. Mm. And for us with our applications, you know, we're saying we're building aerospace grade hardware in space. Aerospace grade hardware is traditionally made of aluminum. It's traditionally made of metal. Only recently have they started making it like composites and things like that. So so that is a like that term being linked to plastic and is a challenge for us. So we generally use the term additive manufacturing to sort of try to be more all-encompassing. And I think that, it's interesting, 10 years ago it was mostly wax, and now it's mostly, and then a few years ago it was mostly plastic, and now we're in this transition of plastic and metal. So there has been this progression. So I think the term will evolve. Maybe 3D printing will just evolve and mean anything that's digitally manufactured, like digital manufacturing, but maybe not.
We don't all need to answer every question, do we?
No, you don't.
Okay.
Unless you have
No,
something
because
pertinent to
all I
that,
can say is
then-
I'm undecided. Depends on the day. One thing that does frustrate me is we have these two terms floating out there, and like you heard me from the stage, I'm saying 3D printing, then I slip and say additive manufacturing. I can lose people in the conversation. So basically, let's just pick something and define it. You know, which one's the umbrella term, which one lies underneath it, if they do, and let's just move forward. But I don't think we have a voice. Man, long-winded answer. I said I didn't want to answer, but years ago, we were looking for a new term to replace rapid prototyping, and people within the industry were trying to concoct it and jam it down people's throats. And I actually penned an article, said, we're wasting our time because we're not going to decide, media will. And media has decided that 3D printing is the term because it's catchy, it gets people thinking. So I don't know that we can have an initiative to make a change. I think it's going to evolve naturally. I just hope that sooner rather than later we have consistency and a clarity of definition.
Thank you. Okay, yes, now we've got some hands. That's good.
First
Okay.
question's here, Jim.
Oh, first question's over there. Thank you, now.
Hi, how's it going? Ajay Deshmukh. I'm caught back in the few years ago in rapid prototyping. So relative to today and all the technology that we're able to see in additive manufacturing, really in the advances, I kind of feel left behind a little bit, but there's still a lot of problems with rapid prototyping, particularly in accessibility. And I would wonder, with the gentleman up on the stage, if they could comment on, with some of the hype, you can't talk about the genesis of the hype without talking about the expiration of patents and how that allowed some of the hype to evolve and investors and consumers to be allowed to look at this product in a more accessible scale, and probably where there's a market that other people didn't think there was. How do you guys see the patent environment, both from it's always a difficult question because of both in the R&D space, which a lot of you are, and in the ability to try to bring these technologies forward and democratize them and allow them to be more accessible. So sort of, where's that balance for you in a space where we all need to, allow each other to build with similar goals?
So I'll start because I'm actually a recovering patent lawyer. I had a patent practice before I ran Main Space. And I'm going to give you sort of a dorky answer. The 3D printing industry can be the next, patent war place. We had it with smartphones, and then we had it with, operating systems before then, and we had it with airplanes at the turn of the 20th century. But the first patent war was actually over sewing machines in like the 1860s and 70s. And the way they, everybody just sued the heck out of each other, and then they finally just said, we can make more money if we just license to one another. And they created, sort of like Impact LA, they created an organization that owned the IP and just licensed it out. This industry will hurt itself if it chooses to just try to enforce. But I think the industry we will see that we are mature once we establish patent pools and license and say, I'm into this awesome thing, but I'm going to make more money ultimately, and the industry is going to move faster and do more cool things if we license. If we grow the pie and are less concerned, if we're less concerned about how big our slice of the pie is and more concerned about the pie growing just as fast as we can grow it.
So, certainly when you deal with investors, intellectual property becomes an important component of all sorts of financings. I think patents in particular are a really interesting tool that I think drives innovation. I think patents are an important part of the literature, just like the scientific literature. I think patents, especially in the context of one has to put down best mode and describe in full detail what people do, and I think that's a really interesting playground with which to drive innovation. To think about how people think about, to see how people think about things and the sort of mindset that they go down and to see the shortcomings, and are there ways to do things differently, and so I think it's an important playground for driving innovation. I think the area that looks increasingly complex to me is the designs of what's being printed and the scanning aspects, and that world looks really, really complicated. And protecting people's designs and how people are going to police that. And I know there are some very creative ways of almost like the music industry that people are moving forward to try to have a marketplace for that, it's going to be an important dimension of the marketplace.
So in general, I guess my sentiment would be that I believe that people that create value, that innovate, deserve compensation or remuneration in kind. There's a lot of different ways that that can play out, but I would say that the governing way that we look at this market is there's so much white space out there in front of us that what we want to do is focus on growing the market, growing the pie, I think is exactly as was already stated. And there's a lot of creative ways to trade value to help that happen, but that's much more the focus. On the other side of the coin, I guess as with all things, there can be a positive side and a negative side, and if we spend all of our attention warring with each other, we're not helping the customers, we're not growing the applications, we're not adding a lot of value to industry. So really that's kind of our bias.
A question that goes towards Carbon3D. You mentioned you have beta customers, I think you referred to them as.
Yeah.
When do you foresee this being available to a retail customer, and do you have any range of price point for the product?
So we have a pretty robust beta program now. We would like another 40 or 50 machines out there to put the technology through its paces, to actually also to help grow up our organization so that we make sure that we're servicing and supporting them, make sure the supply chain is in place. We will come out of beta when we're ready. It's going to be data driven, frankly. Okay. We have some important metrics that we've identified for ourselves, performance bar, and that's not only the technology, but that's supply chain, that's our organization. We don't want to put equipment out there that's not supported well. We're hopeful that we can grow up quickly and do that. And I'm hopeful it'll be this year. But we have dozens of machines out there now, and we'll have quite a few out in the first half.
You say you're looking for more beta customers. How would you become one? How could I become one, or someone could become a beta customer?
So there's some people here that can help you out with that. And when you cross the chasm, I used that description this morning in the sort of Jeffrey Moore analogy from his book of the technology adoption curve. Where you cross the chasm or chasms that may be out there is really a discipline that we're spending a lot of time thinking about. And where are those markets that we can bring something that's that a product or capability that doesn't exist now, to get it into the early majority so that we can proliferate, so that the sales cycle can be collapsed, where the customers in that vertical can be reference customers for their sector. And so, as you can start to see in my talk track this morning, we think automotive is an emerging one for us, and being able to make parts that are real parts, they're actually in the right situation and going through the paces now, and the tier one suppliers to them looks to be an important one. And I suspect athletic sneakers and some medical areas, so we've identified a few places that we think are great places to cross a chasm with and bring something that is needed. And that's how we think about it.
So I have a bit of an industrial structure question for the panel. We talk about democratization and how 3D printing is bringing access to new technology to consumers, to makers, and yet for the past 10 years or so, as the technology has shifted into finished good production, the highest value parts have all been produced by the incumbent players who have been capturing large pieces of the value pie, whether it's a Boeing or an Airbus or a Invisalign. The finished good production is primarily in these large incumbent players. Given that we have a few new technologies that are represented on the panel, I'm curious if the incumbent players will be the ones that benefit most, or if you believe it will be the disruptors that will come in and capture more of the value pie.
So to make sure I understand you right, the question might be, is it going to be the big gorillas that govern the new use cases and things that are being developed? I can speak from experience. I spent the last 10 years building another business, which was focused on mass customization of commercial print. And what we found in those markets is that in some cases, yes, it was the really big gorillas, but in some cases, in many cases, it was the guys in tier 2 and tier 3 who were a little bit hungrier and a little bit bolder, or who didn't carry the big legacy burden and suffer from the innovator's dilemma, if you will. And I think in all things, you want to take a bit of a portfolio approach because you never really know which one is going to be the one that really takes off. And so as we engage all across the spectrum. And it tends to be, sometimes it's even just down to the people in the company that you're talking to that really drives the big breakthroughs because they're just determined, committed that they're going to make something happen and really make a mark.
I think I would add to that. That's a great question. I don't think these are mutually exclusive approaches. And in fact, one way to think about this too that we will all benefit from is we think there's a need for a huge truth in pricing for resins, as an example. And to have to foster an ecosystem where some of the big players, where, look, you start making sneakers with 3D, you're going to drive the price way down on elastomer resins, right? You get into automotive, you're going to drive the price way down on impact-resistant materials. That will have huge benefits to the smaller businesses and the individuals. And so I think they're coupled in some really important ways, and that the economics of this will help drive it, but in both directions.
If I can correct you on one thing, you named Align Technologies, the Invisalign aligners. They weren't an incumbent. They were a startup company founded solely on the ability of what 3D printing could do for them. So there's a new concept, never been done before, that they had to leverage 3D printing to get the product out. So that's an example. But the other side of the coin is we're in a technology that's not qualified, not characterized. So it does, if you've got a demanding application like aircraft, it does take a Boeing or a GE, because qualifying the material, to FAA standards, et cetera, millions of dollars. So you do need some big incumbents to help us get over this hump of, we don't quite know what we have our hands around. And the other side of the coin is, I do think that since it decreases some of the overhead demands for starting up a business, that 3D printing can fuel more competition to the big boys by upstart companies. And the question will be, will they be squashed before they get big enough by the big guys? So I think it's leveling the playing field, quite honestly.
Great answers. Thank you.
Hi, I'm Sheila Stewart with 3M, and we're looking as well for how we can collaborate on the material needs. So I'm curious, we've heard a lot about the different materials that are under development or emerging, but I'm also curious about what secondary processes you're seeing that are needed for 3D printing and what the challenges might be with those.
Yeah. A lot comes to mind. As you start integrating into a true manufacturing facility, first things I think about are just the data that's available and tied to every item that's fabricated, and so that you got a record of fabrication for everything that's made. That digital thread or digital manufacturing, those things that are going to happen. And so once you enable that and you actually have a watermark or some sort of identifier on that part, we just put out a few hundred parts recently, and they all have a mark on them, right? They're all identifiable. And so, that really helps you understand, which machines they were made in, which day, and they're traceable. You got that traceability. And so that allows you to then start using that traceability in the factory itself as you go through additional processing, because the final article of commerce will have multiple things happen to it, right? Whether it's a portion of a shoe or a portion of a car, and being able to trace all that, and then the inventory control aspects of that. So I think there's a lot that's going to happen, and it's very resin dependent, and You know, I think about 3M and all the range of materials from fluoropolymers to other things that I think are going to be great places for a company like 3M to play, not only in materials, but just in the final products that you guys fabricate, from life sciences to others, and dental and other things. And so, you know, I think there's a lot of places for an integrated company like 3M to play a big role in the post-processing and all the add-on beyond, well beyond just the printer itself.
Yeah, well, anybody that knows me knows that I talk a lot about digitization, or the power of digitization. All of that unleashes the ability to have that common thread of information that flows over time, helps us develop analytics and ultimately insights. I think as I reflect back, when we looked at this in commercial print space, one of the things that was interesting was in the early part of adoption, everybody obsessed and focused on the printing process because the quality wasn't quite there, the productivity wasn't quite there, economics weren't quite there, and everybody worked that problem. And then it was like one day, everybody stopped thinking about the production process or the printing process and said, no, it's about everything else. It's about the, because fundamentally a digital production process means that you can have as much complexity as you would like. Therefore, you have a lot of complexity on the inbound side and on the outbound side. By virtue of that, all the solutions need to be chained together to get the value out of that production process itself. As I look at the additive manufacturing space or the 3D printing space, whichever one it is, you know, what we definitely see is great needs for, as Joe said, you know, tracking of information, track and trace, audit, closed-loop quality controls, validation, and really to drive adoption in the industry, because what people want is proof that what's coming out is what it's supposed to be, and that's where all the anxiety is as well. Huge amount of opportunity there.
Yeah, definitely a huge amount of opportunity, and it's everywhere. 'Cause after the build's done, we still have huge lack of capability and processes to do other things to the parts. You know, automation I mentioned, post-processing, Scott mentioned, is a huge issue. You know, so if we really want to bring manufacturing back to North America, you know, by getting rid of labor, well, guess what? We got a huge problem because we got a labor demand after the parts come out of the machine. So you could affect that. Manipulating surface finish. Some parts come out porous, and companies can't use them porous. Sealing solutions, coating solutions. There's some startup companies that are focused solely on dyeing SLS plastic parts, so to add color to them. So your possibilities are numerous, and I'd say your challenge is going to be picking the ones where you can really excel. And I think the best way to figure out where that is pick a couple of technologies and just start interfacing with the users and ask them where their pain points are, and seeing which ones you think you can marry some of your technology, some of your materials, some of your solutions to, and attack that.
Hi, my name is Nick. I'm a med device engineer from the Twin Cities. Just wondering, there's a lot of talk about, you know, 3D printing and case recreations, things like that. But I feel like I'm not hearing a lot about the materials and the bioresorbables, things like that, and the impacts they may have on implantables and med devices, things like that. So just kind of asking the panel, what's your opinion on 3D printing in the med device or the medical industry in general, and where do you think it's going in the future?
One thing that bugs me is people who speak from a different background than they should be addressing. I don't know the medical industry. I don't know the demands for bioabsorbable materials or whatever's required to put in the body, so I don't feel qualified to even answer that question. That's why I intentionally left bio off of my what's new slides. There's tons going on there, but I'm not qualified to even tell you if it's worth looking at. So I'm going to avoid that question just because as a mechanical engineer dealing in manufacturing, I don't think I'm positioned to answer it.
I think I would just kind of echo what Todd said, that it's kind of almost a tangential type of area, but I would say that the way I kind of look at 3D printing generally is you need three good things, right? You need strong mechanicals, you need strong software, and you need strong materials. And for us, on the material side, you know, we're operating in space, so we need things that, you know, can survive vacuum and can survive radiation and have very low coefficients of thermal expansion. So, you know, generally, like the material science is crucial, and you know, but it's an area that there's a whole body of work going on that we all just sort of stand on the shoulders of those giants.
So I do have quite a bit of effort in this area and experience. So as a member of the National Academy of Medicine, I think a lot about the applications for additive in medicine. And we just hired a man, Steve Pollack, who was head of the FDA Laboratory for Devices and has seen a lot of the 3D additive technologies coming through the agency. I started a biodegradable stent company back in 2001, which was acquired by Guidant, now Abbott. We have 80,000 people with their biodegradable stents in them. And so, advanced materials in medical is a huge need and a huge opportunity. And it's one that I think, at the end of the day, is probably the biggest market. And I think it's the biggest market for a lot of reasons. I think, and some of it I alluded to earlier about traceability in manufacturing individual goods. The FDA is going to require that data for approvals. I think the affirming that what you propose to make is actually made, and the data, and doing an audit, and the sensor technology that is live streaming associated with making sure you actually have intolerance, or that you're within tolerance for fabricating something, is going to be really critical. I think having the right material properties for the range of applications. We'll have an announcement tomorrow by one of our partners associated with the JP Morgan Healthcare Conference next week about materials associated with a particular vertical. Sterilizability is essential. Leachability is essential. Contact lenses are UV cured, and you've got, there's a bar of performance associated with that are really essential. So there's a lot coming here, and then you think about tailoring something for an individual and all the imaging technologies that are out there. So if you're designing a device that is wrapping around somebody's tumor, and you had the morphology of their tumor from an MRI scan, and you can tailor that device, local drug delivery is going to be a huge opportunity and need, because a lot of in chemotherapeutics, drugs are systemic, but a lot of these cancers are localized. And so you're going to see a huge swing towards local delivery of medicines. And I think it's just really the beginning. It's probably the richest opportunity for where additive's going to play. There's a lot of exciting things that have been demonstrated by many, many people, and our team that's emerging. And I'm very, very excited about medical, and I think it's going to have a huge, huge impact.
So I don't have the depth Joe has in this space, and I won't add a lot more, but one of the thoughts that really kind of rung the bell for me in this space is that it's traditionally been governed by things that are roughly right rather than exactly right. And so you can take that from a case of somebody who had, there was a guy who had a fall and had part of his skull crushed and had an implant put in place, but the implant was just fitted, and it ended up making it so that he lost the ability to speak and lost the motor skills. With the imaging data that Joe referenced, another company came in and 3D printed something that was exactly right, and as a result of that, he was able to reattain his motor skills and his speech skills. And I think that those kind of examples range from, orthotics through, orthopedics, lots and lots and lots of examples. But you can even take that analogy to, we take drugs in volumes that are defined kind of by sizes, right? And it's not something that's exactly right for you. It's just something that generally applies, and people have kind of dialed in recipes. And so you could imagine a world in the future where people are able to take something that is very precisely dialed in with the analytics that will be possible. So I really resonate with the idea that there is a hugely rich field here.
Thank you. My name is Eric Trubenbach. I work for Teradyne. I have an industrial/automation background, and this question is for everybody but Todd, because he doesn't predict the future, he says. I am frustrated by the materials available. We have metal 3D printers, which are very large and expensive and often require post-machining. We have plastics, which are soft and floppy, and the ABS and things like that. I'm looking for something that has the heat resistance and strength of metal. So we have some noted We have Professor Polymer, Professor DeSimone, who knows an awful lot about polymerization, and HP's high-speed sintering product, they claim, will be metal compatible. Should I be looking for polymer materials that start to achieve the strength that I'm looking for? Or is the metal technology going to become cheap enough that it'll be mainstream? So where's the first industrial mainstream material application going to be?
So there's a lot of different ways to come at that question. I would say that a lot of people recognize the opportunity, and there are technical challenges. But just as an example, the term buy to fly ratio, the idea that you have to buy 10 times to 100 times amount of a material to get down to the part that you actually want to send up in an airplane, means that there's a rich opportunity for additive processes. I think as this industry is starting to reach more critical mass with bigger players, that deeper pockets or whatever, you're going to see advances start accelerating. And having said that, you can also look at things like integrating carbon fiber and things like that, so you can take plastics and emulate the outcomes of metals as they are today. And I think that that's also an area that's definitely going to see growth. And then ultimately, you can see through voxel level manipulation the possible future case where a lot of times we use the word for certain metals because we're actually describing an outcome we're trying to achieve. And there will be many ways of achieving those kind of outcomes with different materials. And so it will be more about what's the problem you're trying to solve rather than what's the material that you're focused on. Having said all of that, I also think that there's some very practical, just blocking and tackling work that needs to be done in metals technologies, and I think there's definitely a need to advance the state of the art there, especially in the post-processing, because that can be as onerous as the printing process itself. Anyways, a very long-winded answer to say that I definitely believe there will be big strides there because there is a rich opportunity.
So I'm certainly blown away by all the materials or all the metals 3D printing. It's just amazing to walk the floor and see what everyone's been doing. It's very exciting. I'm extremely bullish on advanced polymeric adhesives and composite materials, and from elastomers to engineering resins. And yeah, ABS and polypropylene and nylon have been good and will be useful for a lot of things. But the material I unveiled today, the cyanate esters, that's a material that the aerospace companies like yours knows about. They have been the bread and butter of a lot of different kinds of composites. I think the bismuth imides and the other advanced resin materials where you can have modulus of 4 gigapascal and higher in an unfilled form, but now that it can be crafted in complex geometries that you couldn't get through a traditional process. I think the other thing too is advanced high performance elastomers, whether it's a CalRes-like material or used in gaskets and other things. There's a whole space where elastomers used in gaskets have not really been moved forward, and so that you can start off with the kind of designs you want for sealants, advanced sealants. It'll be really useful, and then all those two classes of materials combined with fillers, and is going to enhance the properties even further. So there's a huge opportunity for advanced materials. Ceramers. We hear a lot about polymer. What was the word they use? Polymer ceramics, right? And we saw the paper in Science this past weekend. And back in the '80s, we called them ceramers. They were ceramic precursors to polymers, and we did a lot of that at Virginia Tech. There's a lot of work going on at Virginia Tech in that space, and so there's a huge opportunity for advanced and high performance materials in composites and aerospace.
So I think what I would add there is I think it depends on your requirements. I think we sort of made that point earlier that it's very requirements driven, and you can get there with ABS depending on what you need. But I think depending on your use case, I would say that there are materials like Ultims and Peaks that people are printing in right now. There are some really amazing material science things going on. But if you're, I personally, I think, and I'll predict the future a little bit, if you're waiting for a really strong 3D printer to get to, prosumer level, I think it'll be a race between Carbon3D and metal printing. But yeah, that's my feeling on it.
I am going to answer this. So I'm going to attack it from what I was hearing was price point, though, holding you back. So earlier today, I can't remember who said it, maybe it was Jennifer, likened our industry following the path of the IT industry as becoming more of an IT-driven thing. I'm not convinced of that. I actually suspect that we're going to follow the path of the machine tool industry. And what that means for price point is we've got room to bring the $600,000 systems down, but not to $100,000 in my heart of hearts is what I believe. So what I think is we've got some room to come down and we'll settle in something less, but not significantly less. And then going forward, I think price points for a certain class of machine will remain rock solid for quite some time. A lot of people argue this with me and say, oh, Todd, prices have tumbled. They've just dropped through the floor over the last couple of years. Not for the same class of machine. If you look historically, a machine at this level, yes, it offers more bells, whistles, and features, sells for exactly the same price it did 10 years ago, and exactly the same price it did 20 years ago. If you look at the machine tool industry, that's also true. You want a high-speed, vertical CNC mill, 5-axis, with all the bells and whistles, you're up here, and that price hasn't budged. So I don't hold your breath for a significant price drop. Find an alternative solution if the budget doesn't support going to metals.
Just a quickie. You spoke of sealants and fillers, but as anybody who's read the book The Martian, it was really duct tape that saved the day. Okay. So do you see a role in additive manufacturing and 3D printing for customized adhesives? In other words, where you only need a precise shape and a precise amount, so that you're really talking about something very, very specific? Or is we still have to rely on duct tape in the future?
No, yeah, absolutely you can. If you read the book, The Martian, you'd be much more of a chemist than an engineer. But at the end of the day, it's all about chemistry, I think. And the adhesives that one can generate through these kinds of systems are absolutely possible. And having pressure-sensitive adhesives, but also adhesives that are curable, that are really high-performance adhesives. I mean, polymeric adhesives and composites are going to be are an integral part of what we do.
I've just got one last question. One is the rapid development that we're seeing in 3D printing now at risk of outstripping some of its supporting technologies in how they can keep up? And if so, which of those do you foresee in the near future becoming a problem, if any? Or is everything keeping up with you guys?
Well, I think I was just describing earlier this dynamic of it's all about the printing until it's not, and then it's about everything else. And I think we're definitely going to have that dynamic. I think from our own selfish perspective for HP, our greatest concern is the design tools that actually allow you to take full advantage of the full potential of the technology or the materialization technology. That is a profound change that's required. If you can have the ability to manipulate, 5 or 8 properties at the voxel level, that's going to take some pretty profound work on the design tool as well as simulation, emulation, and so forth. So I think that's a huge area. And then I think there was a lot of, I think Todd mentioned post-processes. I think that as use cases grow, the post-processing part of this will be increasingly important. As the constraint moves in the process, so goes the attention, and I think, again, we'll focus on the printing real hard for a while, and then post-printing is going to get really, really, really important, I think.
Well, the two things that I'm excited about that are growing, that will grow and expand with a future fabricated with light, from our perspective, is one is the chemical supply chain. I think the chemical supply chain, the polymer companies out there will be ready. I think they need to pivot, how they do things. Most times has been small molecules to oligomers to polymers and make pellets and filament. But as you get into when you actually do things the way we do it, you're actually going earlier in that process, and you're actually crafting the polymer while you craft the part. And so, but I think that will help drive down pricing, and so a really robust chemical supply chain will be needed, and you get truth in pricing. And then the other thing that's happening that's going to be really important in a digital manufacturing is everything is happening at the cloud. And so we're doing a lot of finite element analysis and details of these advanced processes as we grow our parts. It's the kind of thing that would, kill a single computer, take hours, but it can be done in minutes in the cloud. And so the ability of tapping that kind of huge amount of computational horsepower to drive these processes are two sort of mega trends, the supply chain and that are going to be really helpful.
So I think the industry is actually already sort of behind the eight ball in at least one regime, and that regime is the design tools for consumer 3D printing. The consumer's not generally sophisticated enough to understand both how to design and then also even how to orient within their printer to have a successful, consistent print. And you can talk a lot about reliability of machines, but some of it also comes down to how the user ability. And I think so. I actually think that today we have this shortcoming in that we don't have design tools that are user appropriate for the price point of devices on the market.
We'll see if they're wallflowers or not. Had a conversation earlier today. Someone asked the gentleman from Czar if they can comment on what that, where we're outstripping something with regards to 3D printing. What isn't keeping up? Metrology. The answer is metrology. We can design it. We can print most things. If we make them too complex, we may not be able to measure them. So we're outstripping the capabilities of metrology, which for manufacturing applications is absolutely critical. Can't measure it, can't prove that it's going to meet your specs, you're done. So that's my answer. Thank you, gentlemen from SAR.
Hi, my name is Paul Lee. I work for Cisco, and I had a quick question around digitizing the file and counterfeiting. You guys are working in technologies around printing. Is there anything around monetizing the design files and limiting the number of quantities you can produce out of your printers? Or
there are people looking at that. Company out of the UK called Grow is one that pops to mind. There's others, but they're looking at an encryption strategy where you've got to release the file to a known source, like contract manufacturer or even internally, and that encrypted file actually keeps count of how many times it's printed, where it's printed, what machine properties are used to make sure it's meeting spec. So we don't have the tools, I'd say, robustly today, but people are working on that problem. That doesn't take care of the scanning issue, if somebody's scanning your design, but if you own the digital property and you're looking to build it, people are working on that.
Yeah, I think that's going to be essential when you start thinking about spare parts and from OEMs and being able to do that. So being able to deal with encrypted systems and where you basically have a watermark in the part and you can trace it will be really important for manufacturers to track what they're doing and track counterfeit going forward.
I think it's actually could be one of the great limiting factors of the scalability of the industry for large corporations to feel comfortable with files flying around the internet. They all watched what happened with the music space and other markets and have a lot of anxiety. So what they really need are some technologies that enable that all to happen in a safe and sane way. I think there's a number of companies that have been looking at this and focusing on it, but I still think that there's a lot more work to be done to bring it to where it needs to be.